For organization members, please include your affiliations, affiliated organization. I'll show the example. Miss Uni, Korea, Ocean, like this. So please, if you don't use this, please write your name and Korean affiliation like this. And to avoid any background noise, we would like to ask you, you keep your microphone muted unless you are speaking during the seminar. For the questions or comment, please use Q&A sessions after presentation. This seminar will be held every first Tuesday of each month, unless we announce differently. Participate, anyone who is interested in marine debris will participate in this seminar. And if you want to participate in this seminar for the first time, please send an email to use this address, ocean@ocean.net. During the seminar, one presenter, usually one presenter will present a paper, usually paper, sometimes reports. Who is willing to present a seminar, please let us know during the seminar, or you can let me know using email ocean@ocean.net. This seminar will cover any field dealing with the marine debris, such as monitoring, policy, or raising awareness. Then I'll start today's seminar. Jason, please.
Yes. Okay. Let me share
please
my
share
screen.
your screen.
Yes. Did I already share? No. So. Can you see my PowerPoint,
No.
my slide?
No.
Okay. So how can I? Oh, okay. I think this works. How about right now?
Yeah, we can see
Yes.
now.
Yes, we can see now.
Thank you. So, okay, this is Jason Hu from Taiwan. We are Indigo Waters Institute. So today I would like to share this article. The title is Marine Litter Storming Washout, Developing the Neural Network to Predict Them. So it's published by two Russian scientists and on this journal called Pollutant. And I just realized this is a very new journal by the MDPI publishers. And I think this journal is not on the like the JCR or some SCI data set, or I mean, it's not a very, it's a very young and new journal, so probably the impact factor is not very high. But I think the topic is very interesting for me, so I choose this one and share for you. So let's start with the abstract. Okay, so the abstract. Is this words too small or still okay? How about like this? Okay, so I just started, and please let me know if the words text is too small. Observation of shows that after storming event, anthropological litter is washed out ashore for a short period of time, providing the opportunity to collect and remove it from the environment. However, the water dynamic in sea coastal zones during and after storm are very complicated, and the transport property of litter items are very diverse. Thus, predicting litter washout using classical numerical models is challenging. So they analyze the methodology and hydrophysical condition in the Pelagic Sea coastal zone to further obtain the data as a training sequence for the ANN, which is artificial neural network. Analyze of the physical process behind a large litter washout linked to open source meteorological like wind speed and direction, and some hydrodynamic reanalyze its surface wave parameters, and use these open source data to time and the location of this washout event. So the detailed analysis of 25 cases of washout observed as shore at this peninsula was performed, and the importance of duration of the storm and its besiding phase was revealed. An ANN structure is proposed for forecasting marine debris washout as its first step in the creation of the neural network-based tool for managers and beach cleaners, helping to plan effective measures to remove plastic and other anthropogenic contaminants from the environment. So at the beginning, I saw it will show some result of the like artificial intelligence or something, but after I read it, they just propose a structure, but I think it's also very interesting. It is very new for me. Okay, so that's it. So they don't show the accuracy of the AI or how the AI looks like, but they only provide a structure and what kind of data they need for this AI. Okay, so the introduction. Currently, models of floating marine litter transport have been developed and described, and they are based on Lagrangian method. However, this method is still too coarse to reproduce dynamic of waves and currents.
We are still on page 2.
Oh, how come? How
yes,
about?
Yes.
Oh, so maybe I can wait for me for a minute. Maybe I can use these functions. So can you see the different slides?
Yes.
Okay, thank you. So this is a sorry, the introduction. Sorry. So they show some limit of the present methodology, and in this area, southern eastern part of Pelagic Sea, and there's massive washout of marine frozen has been experienced for centuries. It is known as such event related to windy weather and certain site-specific favorable conditions, but the exact location and the time is still almost unpredictable. So it's also in very similar, I think, in every beaches in your countries. Like some hotspot is well known by local community and the local volunteers. In some situation, after some maybe weather event or like typhoon, some beaches or some bay will become a hotspot, but probably nobody know how to predict it because it's very site specific. Okay, next is A typical weather condition, the abundance of anthropology macrolither items, it's bigger than 25 centimeters on the beaches in this region. It's average. This number, it's clean in the average. So it's in 1 square meter, there's only 3 to 5 items. But in a stormy washout, it may reach very high level of pollution. Like in 1 square meter, there will be 100 to 120 items. So you can see these two pictures. Left side is I think it's in a general. Oh, both of them are in a massive washout event. So you can see some plastic bottles and some others like maybe plastic bag or some other single-use plastic, and with a lot of algae. So it's in Taiwan after spring, after winter, when the spring is coming, we also have this kind of washout event in our north-facing shorelines. Okay, so prediction of anthropology litter washout should be based upon analysis of two different sides of this problem. And so the first one is the development of a neutral or stormy situation favorable to the occurrence of washout event. The second is the amount of anthropology debris in the seaway and the litter patch similarly to related to human activity in the region, like the rivers, the distance to rivers or cities. So the first one is more like the natural or the weather factors who cause the washout event. And the second will be like the source, like the human activities, or who is the pollutant source. It's more like finding the source. But in their goal in this paper, them focusing on the first one. So it means what's the weather factors or some factors cause the debris straight or wash out to the shorelines. So in their goal of this paper is to analyze the development of a number of meteorological and hydrophysical conditions preceding the massive washout of marine debris on the shore of this coastline. The second is to determine the recurring features and the most influential physical parameter of general wind and wave patterns. And the third is determine the required time period for analyze, which will be used as an input parameter of the AAN. So let's go to the material and the method. So do you have any question right now? No. So so we can take a look of this map. So here is the Baltic Sea. The gray area is the ocean, the waters, and this is Europe. This is Russia, and in this area, in this right, the red frame area, you can see here. Also the gray area is the ocean, the waters. You can see this is a steady area, and this is a oil mining platform number D6 here. So at this platform, they have the aerometer, which is a meter that's log in or monitor the wind speed and the wind directions. So they use the data from the open data from this platform, the wind wind speed and wind directions, and use this data to build reanalyze the wave data of this area. This blue rectangular area. So they have wind data and wave data, but the wave data is come from the wind. Okay, so this red area here is a study area. It's nearby this village, and the length of this study area is 5 kilometers, and they separate into many small sections, and each section will be 100 meters. Okay, so in this, I think it's in this peninsula, in a more wider area, there will be a open data from this institute, the Shirshov Institute of Oceanography. It's a Russian institution, and they have observed 250 cases of debris washout in this area. And based on their data, they can possibly draw some additional conclusion of the washout event. So basically, they have data like the marine debris data, or what kind of algae out there, and the date, and the time, some kind of this data. But they can find some additional information from this data. The information will be like the presence of the algae on the beaches is like the condition of the algae or where the algae is. For example, if the algae are located in the water and at the water edge, algae which is very fresh, so it based on the algae is not dry, it's still wet, something, it's still fresh, or it's pressed, dried, or have a dual look. And in the upper shore, it means the washout is more than 3 days old. So they can use this information for the further analyze or further more data. Okay, so in these 250 data cases, they pull out 58 cases, and they select 25 most typical cases in different times during 2013 to 2019. So here are the 25 cases. So you can see it's observed in different dates and years, and the wind speed, and the wind directions, and the wave height, and the wave directions. So they also found some information about these data. So the wind data has come from the oil mining platform, like I mentioned before. It's 42 kilometers offshore of the northern shore. But the wind measurement is performed at a step of 1 hour and at height of 32 meters. So it's very high. But the marine debris is on the water surface or on the ground. So they use a function to adjust the wind speed data to 10 meters high, and then generate the wave data through this methodology. I don't know the details, but it's called Copernicus, reanalyze data. They use this method to produce wave data from the wind. Okay, so let's keep going. The general environmental scenario. So these are the washout event. They separate the event into two sections based on the local observation and the open the data. So in the section 1, it means the beginning of the washout. So there will be a relative narrow strip. It's about 1 to 1.5 meter wide and about 100 meter long. So it's relative in a small scale. But after the more debris coming, it will become to section 2. It's a narrow strip. It's more concentrate and turn into spot at 6 to 8 meter wide and about 400 meter long. And the next two figure here is about the wind speed and the wave height. So let me explain this figure. The x-axis is the date. So the end here is the washout event recorded by the institute, the local institute on the beach. And after the, so they try to extract the previous data 10 days ago, or in the 10 days before the washout event, because they think it's very critical to get the data 10 days before. They will explain this later. So for in this figure, you can see the y-axis is the wind speed. So you can see the wind speed is relative slower by about maybe it's January 10th and January 11th, the wind speed is getting higher, but go down again and get higher here. And this arrow means wind direction. So you can see the wind direction sometimes it shifts, it changes. And the author says, and in this period, it's very critical. It's about I think it's about 5 days before the washout event, because there will be a decreasing of the wind speed. There's a subside period, and the wind direction also shift. And about the wave height, next figure 6 here, the x-axis is still the same, and you can see the very similar the wave heights shift before 5 days before the washout. Okay, so the duration of the modeling period. So duration of the formation of washout is in table 1, and each case observed was present a set of value of 10 days and with a step of 1 hour. So there will be 240 values like this figure 7. So in this figure 7, the y-axis is still the 10 days before the washout event, and the y-axis is the wave height, because the wave height has a better relationship between different cases. Or let me try to explain, and if you have any question, you can ask me. So in this here, there are different lines, and all these lines are different cases, because they have 25 cases, but they only pick out 5 cases in this figure, and this is most typical cases here. So you can see they are all different cases, washout cases in different years or different months, but the wave height has very similar patterns, like before 5 days, 5 days before the event, there will be a significant high increase of the wave height, and the correlations means that if we put the case number 8 as a basic or the compare data, and we use other wave height data to compare with this, we can find different correlation. So like the highest correlation maybe will be the case number 18. So you can see the pink one and the red one, actually it move very similar. Like here, before 5 days and 4 days, there will be an increase and a decrease, and the marine debris offshore and come up on the beaches. So I can show you with other figure. Sorry, this one is, I think I should choose the. Okay, let me explain this. It's in the supplementary materials. So this is a case number 8. You can see it's 2013 in April. So in this, it's a correlation metric, and it's related to wave height. So basically, the number in these squares are the same number in here. So if the color goes darker, it means they have significant. It have more higher correlations. So you can see many events, they have a higher correlation of between wave height and the wind speed. Oh, sorry. Oh, I'm wrong. I'm sorry. It's, I think the dark color, the lighter color is more correlate. So you can see some light color means the two data is more correlated, I think. So they think the wave height is a better better parameter for compare these data. And they also use this wind rows to try to understand the variation between the washout event. And they find 3 conclusions based on this analysis. First is the washout is observed during the phase of the storm that is subsiding, which means decrease in significant wave height and wind speed. The duration of the subsiding phase is on average about 2 days, which is 48 hours. It means that this is a subsiding phase, and the average 2 days, like here and here. And you can also observe this subsiding phase here, like in this case or this case about 2 days. But in this blue line, it shift to another day later, but it's still about two days or 48 hours, or here 48 hours, the subsiding period. Okay, the next is the mean direction of significant wave during the entire substance phase is predominantly perpendicular to the shore, which means from north or northwest for the considering beach. Actually, it makes sense because this angle of wave will push the frozens, the debris up to the coastline. And they show the direction by these figures. So these three windrows means these three different cases, but all of these cases have very similar wave directions. You can see it's all from north to west, between north and west. And the third conclusion is the minimum significant wave height value in the subtype phase at which washout took place was on average about point at this wave height. Okay, so let's keep going. With this conclusion, they build a training set or a structure of this ANN. So the observation shows that after storm event, a sponge-litter is washed out ashore for a short period of time, providing the opportunity to collect and remove it from the environment. So let me try to explain the structure of the ANN. They have three layers. The first layer is input layers. So they can input these data such as wind speed, wind directions, and significant wave height, mean wave directions, and the storm phase durations, and subsidized storm phase durations. So these are the data they already have, and they input. I don't know how the process is, but they use the ANN or machine learning to generate the output layers, which they have two parameters, two output, which is forecast section of washout. The forecast section, I just mentioned there are two sections. One is the first section, and the second is, and the second sessions. And the time of washout, just the time period of the washout. So, and I will go to the discussion because they only propose these structures. They say they can use this data and to generate this data, this result, but they didn't show the accuracy or others. I think probably they will publish in another paper. So in the discussion part here, the data obtained as a result of this work are observably necessary, but probably not sufficient to create a predictive ANN model of marine litter washout in its natural aspect. For example, in addition of the hydrophysical parameter described in this work, the washout may be influenced by the speed and duration of the current in the coastal zone. According to the preliminary data, the washout of marine debris may coincident with the formation of reef current in coastal zones. And if so, the discussed predict system may also be used to inform people about this dangerous phenomenon. I think that's it. So,
Thank you, Jason.
yeah, do you have any questions?
Do you have any questions or comments? Please tell us now. Any questions?
I think I can, when you think about your questions, I can share some information from our course line, our site. So let me share another screen. So please take a look of this video here, I think. Oh, it's not this one. I can show you another video. So wait, sorry. It's not this one. I mean, in our shoreline, we have very similar situations, like after some like typhoon or some event, there will be a huge amount of debris wash ashore or accumulate in fishing harbor or something. So we use a time-lapse camera. We set a time-lapse camera in a harbor of North in the shoreline of Taipei, the north of Taiwan. And after during a typhoon, so let me explain. I think you can you see the videos?
Mm-hmm. We can see.
Yes. Yeah. Thank you.
Listen, did you take
yes.
this video? Your video?
Yes. I mean, our company we bought a time-lapse camera and built in our friend's roof. I mean, the top of their our friend's building, and try to record in the accumulation event at this harbor. And this is the best angle we can find in this harbor. And after we set up the systems, there's a typhoon coming, so our camera record the whole process.
Oh, that's
yes, I think it's interesting. So every 10 minutes, you will take one photos.
oh.
So you can see at the beginning, the weather is very good, but about September, I think it's second or third, it will become storming, and you can see the wave. So you can take a look of there's some wave here, and as you can see, marine debris accumulate outside, and all of a sudden, wait a moment, you can see the raining, the weather is bad, and in a very, very short times, all the marine debris enter the harbor through this entrance, and you can see in a very, very short time, maybe it's just in between few hours. So they are, but they already accumulate. They already become so-called windrows outside of the near shore, and maybe influenced by some factor, all the debris enter the harbors. And here is a machine, the harbor cleaning machine. It's built by our friends, the Azure project. They present in IMDC. This auto cleaning boat, cleaning the harbor. And most of these items are the volcano, I forgot the name, the natural material from the volcanoes.
Pumice.
Oh, thank you. And so you can see in a very, very short time, it accumulates. But it goes away also in a very short times. So you can see it's not cleaned by people. It's just go back to the oceans. So we try to collect the wind data. It's very preliminary. We just started this project last year, and we are thinking how to analyze this data, and then we found these papers. So it's very similar. In the 5th, January 5th, all the debris come in, and between the event, there will be a significant increase of the wave, but the wave goes down, and all the debris come in. And also they have we have a very similar wind directions. And so in this angle, just about this angle, just about the entrance of this fishing port.
Mm-hmm.
So probably we can think about how to analyze our data. And we also try to, because this wind data we collect from the Weather Bureau, but the station is right on the harbors. So we try to build our wind meter in nearby the camera that can get more local or real-time data for the further analyze. Okay, so that's it.
Thank you. You did a great job.
Thank you. It's my colleague also come work with me.
Mm-hmm.
Any questions?
Any questions? Jerry, do you have any questions about this paper or Jason's presentation?
No, it's not a question. It's just that thank you, Jason. You did a good job. Your research was good. Of course, the similarities between the conditions here with the monsoon winds in the Philippines is creating havoc in the coastline. Especially the 2 days you mentioned is quite interesting for me because it really accumulates so much in the upper end. And it's the most challenging way to clean the environment, the beach. So most people give up on cleaning it because the accumulation is so thick. It's very difficult to remove the debris. And this happens every time because with so many typhoons coming in and storm surges, and as well as the usual monsoon winds. Thank you, Jason, for giving us this outlook. Thank you for the paper. And thank you very much. Bye. That's all.
You're welcome.
Other questions, please?
I have one.
Yes.
As Jason already said, we cannot find any specific result from ANN machine learning and analysis result. As Jason, I expect some kind of result from AI analyze the data and the comparison between modeling and observation, but we can't find that kind of data from this paper. So what is the value of this research or value of this paper? This is just a suggestion of usage of ANN, but we cannot find out any the feasibility or strength of ANN in forecasting the washout of the debris on beaches. What is your opinion, Jason?
Thank you for your questions. I think for us, probably the process they deal with the data, the wind data, have some value for us because we before read this paper, I don't know how to link the data and because we record different events, different washout event, but we don't know how to link them together. The correlation matrix give me some insight, and also the 5 days or 10 days before the event give me some idea. Because at the beginning we only look at the wind data maybe a few hours before the event, but they said maybe 5 days or 10 days. They already influence the washout. So that's the information for me, but I really don't know. I think they mentioned other papers use the AAN, but I don't think it's really related to washout event. They use other, they use AI, but in other data or for other purpose related to marine debris.
Could I mention one thing? When I read this paper, after reading this paper, I thought before 5 days, 5 days before washout, the wave heights and wind speed were decreasing. That's the important point. And Jason, could I ask one thing? This 0 day is washout day, is the storming event day? It's not, right?
No, they. I think they only have the data where the people on the coastline who record the marine debris, but they don't have like when the storms come in, or like the rainfall, amount of rainfall, or the amount of water runoff from rivers. They don't have this relation link or latest data.
Yes, I understand. When I read this paper, that was the biggest mistake, mystery for this paper. If the 0 day is the stormy day, is something weird, and 5 days before washout day, maybe stormy day, I thought, and stormy day, the wind speed and the wind wave height is highest, according to figure 5 and figure 6. And after the day, the wind speed and wave height decreased, and 5 days later, after the events, the washed out happened on the beach, like that. It's just my guess. Frankly, I read this paper very quickly, but I couldn't find the relation between wash day and stormy day. That's a very important point. If they mentioned that thing, is very strange. Yeah, because of that, I couldn't understand where. And one more question from me. Why do they choose case number 1, the correlation figure in the supplementary method, figure 1, 2, is related to the case A, right? Case A is wave height and wind speed. So
yes,
compare the correlation analysis with case A and other cases. So do you know why they choose case A? Or
no, I think they have. Yeah, this is one of the. I think it's very. It's not. It's objective. I mean, they didn't explain why they choose this case A, and they didn't explain how they choose these 25 cases between from the 200 or 58 cases. So I think Yes, they should explain more how they select this sample from a bigger data set. Yes, I think it's important.
Okay, thank you. Any other questions from Ocean or from online participants?
I think there is one more information I would like to share, because sometimes when we discuss this, like the accumulation HASA or WASHA event, we discuss this with like government peoples. Some people will, like Jong-Soo said, they were concerned about the source, where are these debris come from. But some people, especially the local government, they only want to know when will it happen or how to clean it up, because if they didn't clean up in times, they will be blamed by the local people or the tourists. So sometimes the local government don't care about the source. They just want to know when and where. So I think there's still a purpose of predict the hotspot or predict the accumulation event for the clean up purpose. Yeah, that's my idea. Although we all know the importance is the source or the polluters, but sometimes some people still want to know, can we predict them, or how to clean up in the right time, at the right time, something.
I agree. The main point of this paper, we can predict what day after stormy day the debris will be accumulated on some places, and they will wash out to the ocean. So the government can or local officers can guess what day after, I mean, biggest height or wind speed after the day, after 5 days, we can collect debris from the near shore or on the beach. Like that. That's the main point of this paper. Thank you very much, Jason. Some people didn't greet before the seminar. So could you say hello to Mr. Liu Dong-Yu and Ms. Ha, please? Could you turn on your microphone?
Okay. Good morning, everyone.
Good morning.
Good morning. I Yonglong from China. I'm happy to keep in touch with you. Okay, I just listen. It's a good job for Jason, and I talked in Chinese with Jason. We personal in person. Okay, I'm thank you. Okay, I just say so. Thank you.
Thank you. Ms. Ha, please.
Hi, everyone. Sorry, I just I cannot open my camera. It's really nice to get learn about the article that Jason who just tell. I'm sorry that I didn't catch up much with the paper, but if I have more question, I will contact you. Really nice to attend all these frequent meetings, so we can share knowledge about the plastic marine debris. Nice to meet you all.
Okay, thank you. Ms. Icha, please. I think she cannot hear me. Who else from outside? Mr. or Miss Pang in Korean. last time he attended the seminar, but didn't say hello. So, Mr. Marty, would you say hello? Or otherwise, I can tell about him, Mr. Marty, foundation of Pescadores citizen from Taiwan. Hello, and
hello everyone. Hello.
Martin. Nice
My
to meet
name
you.
is Marty. Nice to I from Taiwan Penghu. Nice to meet you all. And thank you, Jason.
Okay. Our team is here joining the presentation today, and thanks to the lecturer, we think that the topic today gives us a lot of knowledge about like wind and wave, the influence of wind and wave. And we think that yes.
Okay, thank you. And I think our participant from outside said hello to us. And Miss Ginger, please. She turned on the video just before.
Sure. Can you hear me clearly?
Yeah, we can.
All right. My name is Chu Jin. I'm working at the Ocean. Recently joined in last January. Merely working on the legal issue and the policy in terms of the marine pollution in the context of South Korea. Nice to meet you all.
Thank you. Mrs. Tara, please. We have a PM meeting at 11:30. So could you tell us just a hello in short? Mrs. Sarah, please. And we have Mr. Jong Kim here. If possible, please say hello. I think he cannot hear me, or it's not possible to say hello. But we have many participants promotion. I'll just show their faces. You have here on 12. Oh. And I have to fix the next seminar. Next seminar is, can I find Google Camera? Google Calendar? Yeah. No. 7th of March. 7th of March will be held. March is International Seminar. Who will present the paper?
Is there any volunteer?
Any volunteers? How about from Greenhouse? Miss Ha, can you do it? Otherwise, we'll choose the people from promotion. Okay, then we will choose a paper and present. Thank you for participation today. See you next month. Bye-bye.